Jai Gurudev student. Good morning. Today we are taking a new chapter. It is Unit 9, Coordination Chemistry, and it is very much important for your entrance exam. So one or two questions must come in your entrance exam from this unit. First of all, to begin with all these things, if you consider the central metal of this one, the central metal of chlorophyll. In the center of chlorophyll we have magnesium metal, hemoglobin, we have iron, and vitamin B12. I repeat, vitamin B12 is also called cyanocobaltamine. So cobalt is the central metal. So in the most of the important compound, the central metal is your transitional element. Clear? So actually these made of complex of these things. Iron in the center, complex structures for hemoglobin, vitamin B12, magnesium in the center. So we are first of all going to define what is coordination compound. Coordination compound are the compounds in which the central metal atom is linked to a number of ions or neutral molecule by coordinate bond. So what are the things are there? Coordination compounds, the compounds in which the central metal atom is linked by a number of ions or neutral molecule by coordinate bond. So you have to have that knowledge of coordinate bond. If I have a coordinate bond is there is cobalt forming bond with ammonia. The two electrons of nitrogen it form bond. Two electrons of nitrogen it form bond. With two electrons of nitrogen it form bond. With two electrons of nitrogen it form bond. So top one, below one. This is the NH3 and the above also NH3. This type of bond actually coordinate bond, where both the participating electron comes from one atom. Now this is what is the coordination chemistry start, where these are actually called ligand. So about ligand we have to read. First of all, we are taking the knowledge of double salt and then complex compound. Now if I have this formula, potassium sulfate, aluminum sulfate dot 24 water. This is the alarm that we have, or the fitkari that is used in our day-to-day life. Now if you add that one into the water, from that we are getting potassium ion, aluminum ion and sulfate ion. Means it dissociate into its constituent ions, potassium, sulfate, aluminum. The sulfate should be 4 there, 1 plus 3, 4. Then water, so actually water remains as water, there is no problem. Now in complex compound what happens? If I have a complex compound, first we are introducing the complex compound K4, Fe, CN6. From that, student, we are going to get potassium ion and Fe, CN6, 4 negative. From that we are not able to get potassium ion, iron, cyanide ion. So that is why the compound which does not dissociate into constituent ions are called complex compound, and which dissociate into constituent ions are called double salt. So this one dissociate into constituent ion, and this one does not dissociate into constituent ions. Here the property of a compound is vanish, and here the property of the complex part remains. So these are the difference between complex salt and double salt. There are many more you will going to get learned. This one do not have coordinate bond. This one having coordinate bond, and this one do not have coordinate. So there are three difference. This one dissociate into constituent ion, this one does not dissociate constituent ion, where the property of the compound is not remain or disappear, where the property of complex part retain. Here coordinate bond does not form, here coordinate bond forms. So there are some three differences you have to learn between them. Then we have to learn about metal ion. Your metal ion, for example, transitional metal ion generally having two types of valencies. One is primary or principal or ionizable valency, another one is secondary or non-ionizable valency. Now if you have look at this formula, then if you have leave that cobalt to form bond with chlorine, it will take 3 chlorine, means COCl3 is formed. So this Cl, how many Cl is there? This is called your primary valence. Primary valency, here primary valency is 3. The cobalt forms 3 covalent bonds. And secondary valency means how many coordinate bond it forms. So here you can tell that it has secondary valency is equal to 6. Actual sense, student, it is like that. Your cobalt forming 6 bonds like that. This is one NH3, 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 NH3. Whole complex takes a charge plus 3. Cl negative, Cl negative, Cl negative. So there are 3 positive forming 3 Cl negative. So that gives you primary valency of 3, and there are 6 coordinate bonds, that gives you secondary valency of 6. So this is what primary valency and secondary valency we have. Next, if I take a complex like that, CONH3 6 times Cl3, in this one, this NH3 is called ligand. This 6 is coordination number. Depends on this 6. Actually depends on this one also. If it is form one bond, then its coordination number 6. But sometimes this ligand can form two bonds. Then 6 to the 12 it may be. Then this one, this Cu, is called central metal atom or ion. Atom or ion. This part, things inside that third bracket, is coordination sphere or coordination entity. Coordination sphere or coordination entity. These are counter ion. The Cl negative, Cl negative, Cl negative is counter ion. So you require to have that knowledge about your counter ion, all these things. Then that ligand that you have discussed here, we will take it once again here. Your ligands is subdivided into unidentate, didentate, polydentate and ambidentate. Unidentate means the ligands having one donor atom. Didentate, two donor atom. Polydentate, several donor atom. Ambidentate, this one is a dilemma. These are actually unidentate, but having two donor atom uses only one, but uses one at a time. So unidentate means if you have NH3, here nitrogen is the donor atom. If you have H2, here oxygen is the donor atom. Only donor atom is one. Now two donor atom, if you have C double O and C double O negative negative, this is one donor atom, this is another atom. This is called didentate or bidentate. Several donor atom, there are sometimes it is found that it is more than two donor atom. For example, EDTA having 6 donor atom. So unidentate, for example, if you have Cn negative, so sometime carbon act as donor atom, sometime nitrogen act donor atom, but both at a time does not become donor atom. So this type of things is called ambidentate. So we'll take one by one them, that will be things will be more clear to you.